Hello dear students, I am Rana Kumar, your physics faculty at Aakash, and a very warm welcome into this last session in which we are going to discuss the problems of very specific chapters, and these problems will be based upon the paper AIATS plus 2025 phase 1 mock test 6 that was conducted on 23rd of February 2025, and we will be discussing the problems of these specific chapters. First one is current electricity, the second one is motion in straight line, third one is kinetic theory, fourth one is thermodynamics, fifth one is alternating current, and the sixth one is EM waves. Very important topic, very important chapters from the point of view of NEET examinations, right? Now, if you are ready and if you are charged up, let's move towards the first problem of this paper, and it was problem 10 of the original paper, and it is based upon the chapter of thermodynamics. A simple theoretical problem from the chapter of thermodynamics. It says that which of the following is not a thermodynamic variable? So they are asking which of the following is not a thermodynamic variable. You have been given 4 options. First one is gas constant, second one is pressure, third one is volume, and fourth one is temperature. Now the point, what do you need to understand to solve this problem is that what is the meaning of thermodynamic variable? What do we mean when we say thermodynamic variable? Okay, so let's try to understand thermodynamic variable. So thermodynamic variable. Okay, thermodynamic variable. State of system. So I have written the definition of thermodynamic variable right in front of you. So you have the definition of thermodynamic variable right in front of you. It says that thermodynamic variable can be defined as the quantities that are used to describe the state of the system. Now the keywords over here is that the state and system. So I hope what do you know what is the meaning of system? Anything which is under a consideration, anything on which we are focusing our attention is known as system. And what is state? State, I hope you know what is the meaning of state. So what is thermodynamic variable? Quantities that are used to describe the state of the system, right? So thermodynamic state को describe करने के लिए, उसको identify करने के लिए आप जिन variables का use करते हैं उसको बोलते हैं thermodynamic variable. Now have a look at the problem. Option 1 says that gas constant. Have you ever described a state, thermodynamic state, with the help of a gas constant? Gas constant is nothing but R. Now, we don't describe the thermodynamic state with the help of R, right? So this is not a thermodynamic variable. Let's talk about pressure. Yes, we use pressure very frequently. We use the thermodynamic variable pressure to identify the state of the system. We write P1, V1 to identify the state of the system. So this pressure is a thermodynamic variable. It is helping us to identify the state of the system. What about volume? Yes, we also use volume to identify the state of the system. So volume is also a thermodynamic variable, pressure is also a thermodynamic variable, and sometimes temperature is also used to describe the state of the system. So temperature is also a thermodynamic variable because it also helps us to identify the state of the system. So pressure, volume, temperature, all of these are the thermodynamic variable. But get this gas constant, definitely it is not a thermodynamic variable, so correct answer should be option 1. And the concept is that it is not used to describe the state of the system, right? Now, if we are talking about the thermodynamic variable, you should be very clear about the further distinction of the thermodynamic variable. So thermodynamic variable, they are further classified into 2 categories, extensive variable and the intensive variable. So first one is extensive, and the other is intensive. First one is extensive. Good evening. Okay, good evening, Dashrath. So first one is extensive, second one is intensive. Now what is the meaning of extensive? Both of these are thermodynamic variables. So this one is also a thermodynamic variable, and this one is also a thermodynamic variable. Now the key point over here is that how do we place a distinction between the extensive variable and the independent and the intensive variable. So the variable which are independent of the size of the system, वो variables जो system के size पे depend नहीं करते हैं. The variables that are independent of the size of the system, they are known as intensive variable. And on the contrary, the variables which depend on the size of system, they are known as extensive variable, right? So I is for independent, I intensive means the variables which are independent of the size of the system, which means that intensive variable are independent of the size of system. Example will be pressure / temperature. And what about the extensive variable? Extensive variable will be, it depends upon the size of the system. So volume will be the extensive variable, and internal energy, or you can say enthalpy. So that's how you divide the thermodynamic variable. One is the intensive, another one is the extensive. One depends on the size of the system, other doesn't depend upon the size of the system. Okay, someone is asking, hi sir, how are you? I'm fine. Okay, so I hope I made the point clear that how to deal with thermodynamic variable, and the correct answer to this problem is option 1, that is gas constant, right? So dear students, if you are clear with this problem, let's move to the other problem. And there you go, right in front of you. It is problem 16 of the original paper and is based on the chapter of current electricity. It says that a flow of 10 raised to the power 12 electrons per minute in a conducting wire constitutes a current of. So you have been given that 10 raised to the power 12 electrons per minute in a conducting wire constitutes a current of. So what is the basic definition of current? It is the rate of flow of charge. The charge flowing per unit time is known as current, right? So you have 10 raised to the power 12 electrons per minute. Okay. So 1 electron, it has a charge of 1.6 into 10 raised to the power minus 19 coulomb. This is the charge on 1 electron. And you have 10 raised to the power 12 electrons. So 10 raised to the power 12 electrons will have a charge of 1.6 into 10 raised to the power minus 19 into 10 raised to the power 12. So the charge becomes 1.6 into 10 raised to the power minus 7 coulomb. This is the charge flowing through the wire in 1 minute. So in 60 seconds, the charge flowing is 1.6 into 10 raised to the power minus 7 coulomb. So in 1 second, or the rate of flow of charge will be 1.6 into 10 raised to the power minus 7 by 60, which if I calculate will be equal to 2.67 into 10 raised to the power minus 9. And this one will be in amperes, right? The unit will be amperes. So the correct answer to this problem is option 3, that is 2.67 into 10 raised to the power minus 9 ampere. This one is wrong, this one is wrong, and this one is also wrong. Okay. Someone is telling to speak in Hindi. Okay. So dear students, I hope I made this point clear how to deal with such problems. Current is the rate of flow of charge. That is the basic concept that you need to utilize while solving the problem. Now let's move forward to another problem. And this is the additional problem. This is the additional problem based on the previous problem. It says that a constant current of 4 ampere passes through a wire for 8 seconds. The total charge flowing through that wire in the given time interval will be. So dear students, if you understood the previous problem, you can attempt this problem, and it is very much similar to the previous problem, but a little bit of twist is given to this problem. And this time you have been given the current that is flowing through the wire, and you need to determine the charge that flows in the given time interval. So if anyone is getting the concept, you can put the answer in the comment box. Meanwhile, I'll solve the problem for you. So I have written that delta Q, charge flown per unit time, constitutes the current. So if I need to calculate the charge flown, it should be equal to I into delta T. So current is 4 ampere. 4 ampere into 8. So 32 coulomb will be the charge flown in 8 seconds. Yes, option 2 is the correct answer to this problem. So this one is wrong, this one is wrong, this one is wrong. It's a simple concept. So yes, 32 coulomb is the correct answer to this problem. Let's move forward to another problem. And again, this problem is again based on the chapter of current electricity, but this time they are testing the concepts of resistance. So resistance is a very frequent topic that you will be asked or you will be tested while dealing with the chapter of current electricity. And this problem was problem 17 of the original paper. It says that a wire of resistance 10 ohm is stretched to twice its original length. The resistance of half the stretched wire is. So let's break the problem into two parts. First, let us try to calculate what happens when you stretch the wire to twice the original length. What happens to the resistance of the wire when it is stretched to twice the original length? क्या होगा resistance को जब आप wire को stretch कर दीजिएगा twice its original length पे. So R it is equal to rho L over A. That's the basic formula that we are going to utilize to solve the problem. R is the resistance, rho is the resistivity. L is the length and A is the area of cross section. Right? So A is the area of cross section, rho is the resistivity, L is the length. Now the wire is stretched to twice the original length. So if you are stretching the wire, the cross sectional area is bound to change. So what I'll do is I'll multiply and divide with length. So it becomes R, it becomes rho L square upon A cross sectional area into length, it becomes volume. Yes, so it becomes volume. So the formula now becomes R, that is equal to rho L square by V. R now becomes rho L square by V. And why did I multiply with length and divide with length? It's because when you are stretching the wire, आप जब आप wire को stretch करेंगे, in that case the length is going to change, and the area of cross section is also going to change. So to determine the impact of length, we multiplied and divided by length, so that we know that in that case the volume is going to remain constant. Anyhow, the volume is going to remain constant. So however you stretch the wire, if you stretch the wire, if you compress the wire, the length is changing, area of cross section is changing, but the concept is volume is going to remain constant. Now in this formula, I have rho as constant, volume as constant. So resistance is varying with L square now. That's why I changed the formula in this form. So from this formula, I can write that resistance is proportional to L square. Right? Now, resistance is proportional to L square. Now let's head back to the problem. So if 10 ohm is the resistance when the length is L, and let R prime be the resistance when length becomes 2L. So from here I can write that 10 over R prime, it becomes L over 4L square. So let L square cancel. So R prime is coming out to be equal to 40 ohm. Right? But the problem is not completed yet. You have been asked the resistance of half of the stretched wire. So let's calculate that. So now you have a wire. It is having area of cross section A prime. It's having length as 2L. So its resistance is R, it is equal to rho into 2L by A prime. Now if you cut the wire to half the length, so R prime will become rho into L into A prime, and its value is 40, we just calculated, so its value will become 40 by 2, that is equal to 20 ohm. Right? So it means that the correct answer to this problem is option 2, that is 20 ohm. Right? So I hope you understood this concept. And if you understood this concept, then have a look at this problem. And it is an actual problem from the, there has been some, this problem has been a little bit jumbled up. So I'll read the problem for you. It says that two conductors are made up of same material, have same length and same resistance. One of them has a circular cross-section of area A1 and other one has a square cross-section of area A2. The ratio A1 by A2 is. So you have been given two conductors. One is conductor 1 and other one is conductor 2. One is having a square cross-section. Its area of cross-section is A1. Let me go through the problem. Just a second. Okay. So I'll draw it for you. So you have two conductors. One is conductor 1 and other one is conductor 2. So you have one of them has a circular cross-section of area A1. Other one has square cross-section of area A2. Right? And they are made of the same material, which means that if resistivity over here is rho, resistivity over here is also equal to rho, right? And they have same length also. So if L is the length over here, L is the length over here. And what else? They have the same resistance also. So resistance over here is R, so resistance over here is R. Now based upon this information, you are being asked to calculate the ratio A1 by A2. What should be the value of A1 by A2, they are asking. Anyone, if you are getting the answer, you can put the answer in the comment box. So they are asking you the, the ratio A1 by A2. So dear students, we discussed that resistance, it is given by rho L over A. Now for the two conductors that we have been comparing, resistance is same, right? Material is same, so resistivity is same. Length is also same. So what about the area of cross-section? Area of cross-section will also be equal to same. It's a pretty simple logic. So if resistance is same, length is same, and resistivity is same, it means that A1 should be equal to A2, which means that this ratio A1 by A2, it should be equal to 1. This ratio A1 by A2 should be equal to 1, which means that the correct answer to this problem is option 3. It's the original problem from the NEET 2020 examinations, right? So I hope I made this concept clear, that how to deal with the problems of resistance. Simple formula, you can stretch the wire, you can compress the wire. You will be asked about how the resistance is changing when you stretch the wire, when you compress the wire. That's the logic, that's the concept you utilize to solve such kind of problems. Now let's move forward to another problem, and it is based on the chapter of alternating currents. And it is problem 21 of the original paper. It is problem 21 of the original paper. It says that the power factor of the circuit shown in figure is. So this time you have been asked to calculate the power factor of the circuit. So power factor of the circuit, power factor. So cos phi is known as the power factor. Right, the term cos phi is known as the power factor, where phi is the phase angle, phase difference, you say, phase difference between current and voltage. So power factor is cos phi, phi is the phase difference between the current and the voltage. And you have been shown a circuit. So this is a series it is a series RLC circuit. So you have been given the series RLC circuit and you are being asked to calculate the power factor. So let us first calculate the phase difference between the current and the voltage. So if I try to draw the phasor diagram, this is VR and current will be in this direction only, right? And voltage across inductor, it varies by a phase difference of pi by 2. So VL will be here, and let's talk about VC. It comes over here. So net voltage, it comes over here, and this angle, this is known as the phase difference between the current and the voltage. And we can use the same concept for the impedance triangle also. See, if this is R, then this will be XL and this will be XC. I'm assuming that XL is greater than XC. So it means that the net impedance will be along this direction, Z, that will be equal to under the root of R square plus XL minus XC whole square, right? And this angle will be your phi. So this cos phi will give you the power factor, and cos phi from this impedance triangle, it will be equal to R by Z. Cos phi is coming out to be equal to R by Z. Someone is asking me, how are you? I'm fine. So cos phi, it is equal to R by Z. Now you just need to calculate R by Z. So cos phi, what is the value of resistance? It is 80, and let's calculate the impedance. So it will be equal to under the root of R square plus XL minus XC whole square. So XL minus XC whole square. So it will be equal to 80 upon under the root of 80 square, and XL minus XC will be 100 minus 40. It becomes 60. So 80 square plus 60 square. So it's a simple Pythagorean triplet. 80, 60 will give you 100. So cos phi, its value is coming out to be equal to 80 by 100, which means it is equal to 0.8. Power factor of the circuit, we just calculated, it is equal to 0.8, and it is given to you in option 3. Now dear students, if you understood how to calculate the power factor, give me the power dissipated, average power for this RLC circuit. How to calculate the average power for this RLC circuit? If you know how to calculate, give me the answer to this problem. Average power for this same circuit, P average. Anyone? P average? Okay, I'll write the formula for you. Average power, it is a very standard expression. It is equal to VRMS into IRMS into cos phi. And if IRMS is not given, you can modify this formula. VRMS, in place of IRMS, you write VRMS over the impedance, and cos phi, it again become R by Z. So it is coming out to be equal to VRMS square into R by Z square. So VRMS square into R by Z square, VRMS is given to you as 220, R is given to you as 80, and Z is, you just calculate, it is equal to 10. So VRMS, it becomes 220 into 220 into R is 80, and upon 10 into 10. It should give you the answer to this problem. So I hope you understood how to solve such kind of problems. In this problem, you are being asked about the power factor. आपसे ये भी पूछा जा सकता है how to get to the average power. What is the average power dissipated? So that's how you calculate the power factor. Or if you got the power factor, you can also calculate the average power dissipated. Now, if you understood this, let's move forward to another problem. Again, based on the chapter of alternating current, and this time you have transformers. It says that problem 22 of the original chapter, it says that a transformer has 100 turns in the primary coil and carries 8 ampere current. So for the primary coil, you have the 100 turns and carries 8 ampere current. So if I try to put the data, so number of turns in primary is given to me as 100, and I have been given the primary current as 8 ampere. Right? If input power is 1 kilowatt, I have been given the input power also, P input. It is equal to 1 kilowatt. The number of turns required in the secondary coil to have 500 volt output will be. So you have been you need to calculate the number of turns required in secondary, and the voltage across the secondary is given to you as 500 volt. Vs is given to you as 500 volt. So you need to calculate the number of turns. So dear students, what are the basic concepts that we need to utilize? So we know that number of turns in secondary upon the number of turns in primary. This ratio Ns upon Np, number of turns in secondary upon the number of turns in primary, it will be equal to voltage across secondary upon the voltage across the primary. Vs by Vp. Now, if it is a step up transformer, in that case, Ns will be greater than Np, which means that Vs will be greater than Vp. And if it is a step down, in that case, Ns will be less than Np, which means that Vs will be less than Vp. Right? These are the basic concepts. What else? So output power, it will be written as Vs Is, and input power will be written as Vp Ip. Right? So now we need to calculate input. We have been given the input power, primary current, number of turns in primary. We need to calculate number of turns in secondary. So to use this formula, Ns by Np, we first need to calculate Vp. Because we have Np with us, we need to calculate Ns, we have Vs also, but we need to calculate Vp. So how to calculate Vp? We can calculate Vp with the help of input power. So input power is given to me as 1 into 10 raised to the power 3. It will be equal to Ip into Vp. What is Vp? Okay, Vp, okay, Ip is given to me as 8 ampere. So just a second. It is 8 into Vp. So Vp will be equal to 10 into 10 into 10 by 8. So 2, 5, 10, 2, 4, 4, 25, it becomes 125. 125 volt is the value of Vp. So use Ns over Np to be equal to Vs over Vp. So Ns you need to calculate. Np has been given to you as 100 and Vs is given to you as 500. So Np is given to you as 100, Vs is given to you as 500, and this has been given to you as 125. Right, so Ns from here, it will be equal to 5 into 100 into 100, and this 125, it can be written as 25 into 5. So 520 and 25 into 5. So 5 into 5, 25, 25 to 500. So Ns is coming out to be equal to 500. Right? Which means that correct answer should be, oh just a second, I just missed the calculation. So 125, let me check the calculation. So, okay, let us do it again. So Ns we need to calculate, Np is given to me as 100, okay, and 500 by 125, 500 by 125. So, okay, so let us calculate it again. Little bit of calculation mistake, please ignore it. So Ns we need to calculate, Np is given to me as 100, Vs is given to me as 500. Yes, 400, yes, Vs is given to me as 500, and Vp I just calculated, it is 125. So Ns I need to calculate, it will be equal to 5 into 100 into 100 over 25 into 5. So 25 into 4, it is coming out to be equal to 400. I'm sorry for the calculation mistake, it is coming out to be equal to 400. And this one is wrong, which means correct answer should be equal to 400, and this is given to you in option 3. Right? Yes, 400 is the correct answer. Very sorry for the calculation mistake. So dear students, I hope you understood how to solve the problem of transformers. Now if you understood it, let's move forward to problem 23, and it is a problem based on the chapter of electromagnetic waves. And it says that this equation, the Maxwell equation, closed integral of B dot dl, it is equal to mu naught times I plus epsilon naught d phi E by dt is a statement of. It is a statement of. Yes, I got the answer. Yes. Now let's head back to this problem. So you have been asked that this statement B dot dl, it is equal to mu naught times of I plus epsilon naught d phi E by dt. It is a statement of, okay, and someone is giving the answer. First one is the Faraday's law of EMI, no. Modified Ampere's law, I think the correct answer is modified Ampere's law. Gauss law of electrostatic. What is the expression for Gauss law of electrostatic? It is E dot ds is equal to Q enclosed divided by epsilon naught. And what about the Gauss law of magnetism? It is closed integral of B dot ds to be equal to 0. So this equation that has been given to you, it is a modified form of Ampere-Circuital law, which means correct answer should be option 2. Now let me give you some history or context about the modified Ampere-Circuital law. So according to the Ampere-Circuital law, B dot dl, ये आपने moving charges and magnetism वाले चैप्टर में पढ़ा होगा, that this line integral of B dot dl, it is equal to mu naught times the I enclosed, right? What इस equation का क्या मतलब है? What is the meaning of this equation? It tells you that a current carrying conductor can produce magnetic field, right? But the the context or the hidden concept over here is that in this case the electric field is constant. It is not varying with respect to time. So for this equation where we write that line integral of B dot dl, the standard form of Ampere-Circuital law, it is equal to mu naught into I enclosed. Here electric field is not changing with respect to time, and this current carrying conductor can give rise to magnetic field, right? Now what happens when there is a change in electric field, when electric field is changing with respect to time, right? So for that, consider a parallel plate capacitor, right? And assume that this capacitor is being charged. Now as this capacitor is being charged, you know that there will be variable electric field between the plates of the capacitor. जैसे जैसे capacitor charge होगा, electric field between the plates of the capacitor, it will be varying with respect to time, right? But if you take a cross section like this, and if I ask you to do the integral B dot dl onto this, so you can see that no current is flowing through the conductor while this capacitor is being charged. Charge will be here, charge will be here, but it will not be stored, it will not pass this cross section. So closed integral of B dot dl should be equal to 0. But if you bring a magnetic needle in the vicinity of this coil, it will deflect. अगर आप magnetic needle को इस coil के vicinity में लाइएगा, तो the magnetic needle will show you the deflection, which means that there is a presence of magnetic field right over here, but your Ampere-Circuital law is not able to identify the source, because according to this there should be zero magnetic field, but if the magnetic needle is showing deflection, then there has to be magnetic field. But what is the name of this new source? What is this new source which is able to produce the magnetic field? The new source is called the time varying electric field, right? So this time, the time varying electric field is giving rise to magnetic field, and for that we write that closed integral of B dot dl, it is equal to mu naught epsilon naught d phi e by dt. What is d phi e by dt? It is the rate of change of electric flux. Electric flux, the rate of change of electric flux. So if electric field is varying with time, it will give rise to magnetic field, right? That is the that is what scientists discovered while going through the electric field which was varying with time, right? Now suppose that you have both, you have a current carrying conductor, you have the charge flowing, as well as you have the time varying electric field also. In that case, the closed integral of B dot dl, it will be equal to, yes, it will be equal to mu naught into I plus mu naught epsilon naught d phi e by dt, right? So closed integral of B dot dl, if I calculate this, it becomes, let me take mu naught as common. So it becomes I plus epsilon naught d phi e by dt. And what is the mean? What is this called? If this is the conduction current, then this term epsilon naught d phi e by dt, it is called displacement current. So dear students, I hope you understood what is how we got to the modified Ampere-Circuital law. So this expression, this very standard expression, closed integral of line integral of B dot dl, it is equal to mu naught I times epsilon naught d phi e by dt. It is a standard expression for the modified Ampere-Circuital law, right? So dear students, I hope this point was clear to you. And if this point is clear to you, let's move forward to our next problem. There you go. again on the chapter of AC, problem 42. It says that a capacitor is in series with a resistance of 30 ohm and it's connected to a 220 volt AC line. So this time you have a resistance that is connected with the capacitor. The value of resistance is 30 ohm and it is connected to 220 volt AC line. The reactance of the capacitor is 40 ohm. So we have been given the value of XC. So let me quote the data for you. Resistance is given to you as 30 ohm. XC is given to you as 40 ohm. VRMS is given to you as 220 volt. Okay. The net react. Okay. What is the what is the power loss in the circuit? So this time you have been asked the power loss in the circuit. How to calculate the power loss? Which इससे पहले cost factor वाले problem में we calculated how to get to the average power, and this time this average power is being called as power loss. So again the formula will be VRMS into IRMS into cos phi. Right? This time you have not, this time there is not a RLC circuit, but it is a RC circuit. So let me modify the expression for you. I have been given the VRMS, so I will write it as it is. But मुझे IRMS की value नहीं पता है, तो in the place of IRMS, I will write VRMS over Z. And cos phi, again, cos phi will be equal to R by Z. So now you have VRMS, you have R, but how to calculate the value of Z? So this time you have a resistor and a capacitor that is connected to an AC source. Right? So if I try to get to the impedance triangle, this is R and this will be XC. So impedance Z will be equal to under the root of R square plus XC square. So R square plus XC square under the root of 30 square plus 40 square will give you Z value as 50 ohm. 50 ohm. So let me get to the answer. So you have VRMS as 220. Yes, someone has given the answer and I think it's right. 220 into 220 into the value of resistance is 30 and the value of Z is 50. So upon 50 into 50. Little bit of calculation, but you have to get to the approximate answer, not the actual answer. So let me cancel the zeros for you. So this is 5 into 6, 30. So this is, if I do the calculation, it is 22 into 22 into 6 by 5. So 22 into 22 is 484. This part, it is 484 and this 6 by 5 will become 1.2. So this value, if I am being asked to calculate the approximate value, this 484 into 1.2, 484 into 1.2. It will be if the value is suppose alpha, it will be less than 484 into 2 is what? So it is more than 484 and it will be less than some 968. So the value should be between 484 and 968. Let me go through the options for you. And yes, you can see that 580 I think is the correct answer to this problem, right? So approximate analysis, 580 watt should give you the correct answer to this problem. You can calculate it, it will be equal to 580 watt only, right? So dear students, I hope you understood this problem, how to calculate the power factor. We just discussed this concept of average power in the previous problem, and again the same concept was being tested in this paper only. So I hope this problem was clear to you. Now we have problem 45 of the original paper and it is based upon the chapter of thermodynamics. It says that in adiabatic change between system and surrounding. So this time the problem is based upon the adiabatic change. And I hope you know what is the key concept for the adiabatic process. Now let me go through the options for you. First option says that there is no transfer of heat, hence temperature remains constant. Okay. So in adiabatic process, we know that there is no transfer of heat between the system and the surrounding. The basic concept, the key concept for the adiabatic process is that system और surrounding के बीच में किसी भी तरीके का heat interaction नहीं होता है. That is the key concept for the adiabatic process. So first option says that there is no transfer of heat. Yes, it is clear, but hence temperature remains constant. But हीट का ट्रांसफर नहीं होना सही बात है, बट it tells you that temperature remains constant. Now what is the meaning of temperature remains constant? It means that the internal energy will remain constant. Now from the first law of thermodynamics, delta Q, it is equal to delta U plus delta W. We are talking about the adiabatic process, so this delta Q will be equal to 0. It means that delta U plus delta W will be equal to 0. So in adiabatic process, any kind of work interaction, either the work done on the system or the work done by the system, both of that will come at the cost of internal energy. चाहे आप work करें या चाहे system आपका work कर रहा हो या system पे work हो रहा हो, it will come at the cost of internal energy. And if it is coming at the cost of internal energy, it is bound to change, right? So based on the conservation of energy, अगर work हो रहा है, it will be at the cost of internal energy. If the work is being done on the system, again, it will increase the internal energy. So temperature cannot remain constant. This option is absolutely wrong, right? Let's go through the second option. It says that there is transfer of heat, so temperature remains constant. Okay, this is absurdly wrong. The key concept of adiabatic process is that there is no heat interaction between the system and the surrounding. So option 2 is completely wrong. There is no chance of getting the right second option. Let's talk about the third option. There is no transfer of heat, but temperature may vary. Now this one seems correct. There is no transfer of heat. This is the basic concept of the adiabatic process. And see, delta U plus delta W, from the first law of thermodynamics, it is equal to 0. Delta U plus delta W. Now if work done is being done by the system, in that case delta U will decrease. And if we are talking about the ideal gas, for that the internal energy is a function of temperature. In that case, the temperature is going to decrease, right? But if work done is less than 0, in that case delta U will increase, which means that temperature is going to increase. So temperature may increase, temperature may decrease. मतलब increase or decrease, for the to whether comment whether the temperature will increase or decrease, you need to know what is the work interaction of the system, whether work is done by the system or whether the work is done on the system, right? So that's how you discuss. So option 3 says that there is no transfer of heat. Yes, it is true, but temperature may vary. Yes, this one is perfectly correct. Let's talk about the fourth. There is fast transfer of heat as well as variation in temperature. Now it says that there is fast transfer of heat. In adiabatic process, there is no transfer of heat. So what is the question of asking whether the heat transfer should be fast or slow? जब heat transfer हो ही नहीं रहा है, so what is the point of asking whether the heat transfer is fast or slow? So this one is wrong, as well as variation in temperature. Variation in temperature is correct, but there cannot be fast transfer of heat or slow transfer of heat, because the key concept over here is that there is no transfer of heat, right? So dear students, if I sum up the conclusion for you, it says that if adiabatic expansion is taking place, in that case the work done is greater than 0 and delta U, it decreases. So it means that temperature decreases. Remember this as a direct result, that if adiabatic expansion is taking place, in that case work done will be greater than 0, internal energy will decrease and temperature will decrease. But if adiabatic compression is taking place, in that case work done will be less than 0. It means that delta U will be greater than 0. And if internal energy is greater than 0, it means that temperature will increase. So in adiabatic compression, the temperature will increase, and in adiabatic expansion, the temperature is going to decrease. But the key concept over here is that there is no transfer of heat at all. And if we talk about the isothermal process, in that case, there is no change in temperature. For the isothermal process, the key concept over there is that the temperature of the system is held constant. So if the temperature of the system is held constant, and if it is a system of an ideal gas, then you can say that the change in internal energy will be 0, or I can say that the internal energy will be constant, right? So for for adiabatic process, the process equation is PV raised to the power gamma equal to constant, and here gamma is your adiabatic index. Right? And for the isothermal process, PV is constant. PV is constant. This is for the isothermal process. Here your temperature is constant, which means that delta U is equal to 0. And then you also have the isochoric process in which delta W is 0. So in that case, delta Q is equal to delta U. So I'm telling you that one process is there also, isochoric. There is a isochoric process also where delta W is 0. So you need to be thorough with all the process, but the correct answer to this is option 3, that is there is no transfer of heat but temperature may vary. So dear students, I hope I made all the concepts clear to you. I tried my best to get the concept delivered to you and to discuss the problems of this paper, and I hope you understood all the concepts. Work done by the system then temperature. Someone is asking me work done by the system then temperature. If I need to comment that what will be the temperature when work done by the system, so you should mention the process also. Then what is the process that you are asking? We cannot give a vague answer that what should be the work done then temperature. Work done by the system then temperature. You should mention the process also. So dear students, ignoring that, I hope I made the concepts clear and it was delivered to you with a lot of efforts. I hope it was clear to you, and keep practicing, and all the very best for your examinations. Thank you for watching the video.